What is line? Differences between linearity, independence, normality, and equality of variance. Linearity versus independence versus normality versus equality of variance. Linearity refers to the linear relationship between two or more variables which is represented by a straight line in graph. Whereas independence of residuals means that the errors in your model are uncorrelated to each other. Whereas the residuals are assumed to be normally distributed with a mean of 0 and a constant, yet unknown, variance. Whereas the equality of variance means that the degree of variability of residuals is equal across the subpopulations with different fitted values, also called as homoscedasticity, which means having same variance. The aim of linearity is to describe the relationship between two or more variables when they tend to change at the same rate. Whereas the aim of independence of residuals means that the error terms, residuals, for different observations are not correlated with each other. Whereas the aim of normality of residuals is to test the data is normal or not. Whereas the aim of equality of variance or homoscedasticity is to describe the consistency of variance in a dataset. The nature of linearity is based on the linkage between x and y is linear. Whereas the nature of independence is based on observations which are independent of each other. Whereas nature of normality is based on any fixed value of x, y is normally distributed. Whereas the nature of equality of variance is based on variance of residual is the same for any value of x. Linearity is represented by scatter plot, whereas independence is represented by residual plot, whereas normality is represented by histogram, normal percentile, percentile, p plot, normal probability plot, and tests like skewness and kurtosis, Jark-Berra test, Shapiro-Wilk test, etc. Whereas equality of variance is represented by scatter plot or residual plot. Based on linearity is based on means of subpopulation of y all lie on the same straight line. The scatter plot of x and y should show a linear tendency. Whereas computation of standard error relies and based on the assumption of independence, so if you don't have standard error, say goodbye to confidence intervals and significance tests. Whereas the assumption of normality and regression are based on three ways, that is, for confidence intervals around a parameter to be accurate, the parameter must come from a normal distribution. For significance tests of models to be accurate, the sampling distribution must be normal, and to get best estimates of parameters, that is, betas in regression equation, residuals in population must be normally distributed. Whereas the error terms of all the subgroups are assumed to have the same shape of distribution, which is normal distribution with mean of 0 and variance of a constant denoted by sigma square. In short, we draw a scatter plot of residuals and y values. Y values are taken on y-axis, and standardized residuals are then plotted on x-axis. If the scatter plot follows a linear pattern that shows that linearity assumption is fulfilled. Whereas independence of residuals means that the error terms, residuals, for different observations are not correlated with each other, otherwise autocorrelation occurs when the residuals are not independent of each other. Whereas the normality of residuals is crucial for the validity of the prediction intervals produced in forecasting. Whereas the variance of the residuals should be consistent across all predicted values. It is important tip that is, if 3 assumptions of linear regression model fulfilled, then 4 assumption automatically fulfilled. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.